are studying the ADS, the Automatic Dependent Surveillance. The as general aspect, we can see that this system is called dependent because it's 100% dependent. Okay, so all the information is computed on board. Okay, so we only need some ground infrastructure, okay, just to process, just to decode and collect the signal coming from the aircraft. And we have two types, ADS-C and the ADS-B. Okay, let's start with the ADS-B. And I want to open the screen to draw the architecture of the ADS-B. Okay, let's think that we have two planes, one here and another over here, and we have the, sorry because my design is not super nice, but this is the GNS, okay, in order to provide the position and the different magnitude, okay, in order to to acquire the position, okay, and the aircraft inside is propagating the signal, okay, so this aircraft is sending to other aircraft in the surrounded area and also for the ADS-B ground station. So this is the ADS-B ground station, okay, and oh sorry, let's use a different color, see, green, okay, so this guy over here, the same thing, okay, so we are also collecting the signal coming from this aircraft here, okay, so we know that this aircraft is over there, okay, because we are able to receive and decode on board the signal, okay, so sorry, and then the ADS is sending the information to the surveillance data processor, okay, to extract the position and then to show the aircraft into the air traffic controller screen of this place. Okay, so this is basically the architecture of the system. So the aircraft are collecting computing using the global navigation satellite system, okay, the position, or also they can also use the inertial navigation sensor, okay, to get the position, okay, and then this signal is broadcasted to everywhere, okay, and is periodically transmitted. So that was developed. The first design was from 1970, okay, and as we mentioned, a signal is transmitted periodically in is the what is called the 1090 megahertz Mod S extended squitter, okay, the ES is called. So we need a Mod S transponder, okay, and super important, we don't need any interrogation, okay. This signal is broadcasted, okay, from time to time with different messages, okay, and we mentioned this already, and only a ground antenna is needed, okay. This is a very simple antenna, okay. It's this antenna over here, Okay, so it's like the DME. So it's super simple and super cheap. Okay, so we only need that, and is, as I mentioned already, is simple and with a very low cost. Okay, and this can be used for both air ground ATC application, but also air applications, as we mentioned already. And the ADSC, okay? So the ADSC, let's draw again the schema. So we have one aircraft over here and also another one. Now we have the GNSS and also the satellite communication. Okay, and here on ground we would need the VHF data link uh, ground station, and a satellite ground station. Okay, so let's again the colors. So let's the GNSS is sending the well is the aircraft is using the GNSS to collect the position, their position, okay, and then the colors. So then the aircraft is computing the information to the SAT and the SAT to the ground station, and the color to the VHF. Okay, in case we have a visual uh, uh, we are close to the station and not in the ocean, for example, and we can make use of the VHF data link. Okay, and again, so after this, the information is propagated to the surveillance radar processor. Okay, in order to compute the aircraft positions. So ATC contract typically is used in oceanic and also remote areas, okay, where we don't have radar. Okay, we see that the frequency that where we are transmitting these messages are not very high because it's super expensive. Okay, so we are using the satellite communication or VHF data link, which are very expensive technology. Okay, and the message are delivered in using ARINC, SITA, using satellite and VHF, and the information that we can send is position, predicted route, velocity, even meteorological data. Okay, so the position is composed, as we mentioned, with the satellite information and the inertial navigator sensor. Okay, and we are well is defined for a type of contract. Okay, where the air traffic controller may require periodic contract. So let's say the air traffic controller is not is needing the position, for example, every 50 minutes whatever. So they can request like a periodic contract. Also, the second one is an event. The air traffic controller can set up a contract, like if the aircraft is deviate from this altitude, from this position, if the speed increase that level. So this is the message they can establish, and also on demand. It's like they need an update of position, so they can set up this kind of message. And finally, the fourth is not demanded by the air traffic controller. Is from the single type of contract that is established on board from the pilot. Okay, it's in case of an emergency. Okay, and this is all about the ADS-B.